I am going to paste one more credential for you guys into the chat. This is going to allow you to log on to the Thousand Eyes GUI with a read-only account. The reason why it is read-only is because in this lab, we're kind of forcing you to do everything through the API. So you won't be able to do anything through the GUI, but you can poke around. So quickly, what is Thousand Eyes and what do we have set up here? Well, Thousand Eyes is a monitoring tool that allows you to actually monitor any network, device, router, switch on the internet. So it gives you a view not only of your own local network, but of the network up in the cloud, the underlay, as well as like the core routers and switches on the internet. And it has a very rich graphical interface. It also allows you to install agents. So there's various types of agents. We've installed agent to servers, which are strategically located agents. And they run on a Linux machine. So in this case, I have agents installed, I believe, in, let's just take a look here. I have installed enterprise agents into Columbus, Ohio. We have one, as well as San Jose. And then I believe we have Mumbai, as well as Dublin, Ireland. So very quickly, these are just EC2 instances that were deployed via the lab pipeline with a Thousand Eyes enterprise agent. What these do is they report back into the Thousand Eyes cloud agents. If we click on cloud agents up here, we'll see that Thousand Eyes as a company has cloud agents in all these areas. So that's, I guess, why they call it Thousand Eyes. They have 1,000 eyes or more all over the internet. And what that enables them to do is to provide us with the ability to drill down and to look at any, even the BGP, the underlay on any network on the internet or in private networks as well. So these agents report in on port 443 to the cloud agents. And what we're going to do today is, it's one thing to add in the agents, but it's another thing to set up tests. So after we add in the agents, which have reported in already to the SAS controller, what we do is we set up tests. And you can see we have a few tests in here from yesterday. And when we set up tests, we're basically telling it how we want to monitor the network. So as you can see, there's a bunch of different options here that we can enable. There's also an advanced tab. And so today what we're going to do is we're going to first show you how we programmatically authenticate through to this API. And then what we're going to do is we are going to, via the API, create tests and add all the agents into the test. So if I were to add a new test through the GUI, it's quite laborious, and I can only add one test at a time. And then I would have to click a drop down and I would have to select all my agents, right? So you can imagine if you had 10 or 20, 100 or 2,000 agents, you wouldn't want to go through the GUI and do this, right? It would take forever. So we want to do a bulk automation through the API. So I'm not going to spend a lot of time on the Thousand Eyes GUI. We have separate trainings for that. This one really focuses on the API. So let's go ahead and start out here. So the first thing I'm going to do is I'm going to go in to open up my IntelliJ. And I anticipate that most of you have an IDE installed. If you don't have one installed, I recommend IntelliJ. That's what we're going to be using in this lab. So I'm going to go ahead, open up my training. And of course, I have already cloned my repo, which is the Cisco FSO Labs repo here. And hopefully this is big enough. If it's not big enough, let me know. I can make it bigger. All right. So where we're going to start out today is in the lab tasks folder. And we're going to go into Thousand Eyes and we're going to go into TEAPI input. And we're going to switch into that directory. So from IntelliJ, I just right click, copy path. And I'm going to get into that directory, PWD. Okay, I am there. And I'm just going to quickly make my font a little bit bigger. I think it may be a little too small. So font size 16. Let's try 20 here. Okay, that's a bit better. All right. So what I'm going to do is I'm going to log into my Concourse CI tool here. And I'm going to paste the login command into the chat for you guys as well, so that you can perform the same step. So give me a second here. I have a couple other screens that I'm working from, and I'm just grabbing the command and I'm going to paste it into the chat as well as into my window. So this is the command I'm going to run. Okay. Oops, 1 second here. US East 2A. Let me repaste that into the. One thing here, when you guys paste this command into IntelliJ, it takes the double dashes and it makes them as a like a single dash. So you're just gonna have to fix that up and make it a dash dash. Okay. Okay, so let me just explain this command. I'm going to paste it again into the chat. So everybody can run this command from your IDE. Make sure you're in the directory that I provided. And I will actually paste that directory into the chat as well from the root of the repo. So you're going to do cd into here. And then you're going to run this command. This is going to log you on to the Concourse CI tool, which is our pipelining tool. All right, and I'm going to explain this command. Fly target is equal to our team. So our team name for this is Cisco FSO Labs. Login, we pass it the URL, and then we specify our team again, and then we give it username US-East 2A and password US East 2A exclamation mark, and it will say target saved. So now we have logged in and authenticated to our CI tool. This CI tool on the back end, by the way, it's just a standard Helm chart, the vanilla Helm chart of Concourse. And to integrate it with Vault, all I did was create, I'll show you very quickly so you can understand the back end too. Because DevOps, right? DevOps, we don't just do API integrations, we build the entire infrastructure and automate it as well. So that's part of the DevOps job. So I'm just gonna go into the Vault and quickly show you the integration. So there's, no smoke and mirrors. Everybody understands every component of the lab. So I have, I auto deployed a little Kubernetes cluster up into AWS. And after I did that, I deployed 2 Helm charts, Concourse and Vault. And after I deployed Vault, I created a mount point for Concourse. I created a mount point for our team. I created a policy which says allow the team to allow the token that is a member of the team access to this mount point to read, create, update, and list. Okay, so now if I go back to the mount point, Cisco FSO Labs, I created a token for Concourse, and then I did a Helm update specifying that token. So Concourse effectively is using the HashiCorp Vault as an artifactory, not just for credentials, but for config files and anything that the pipeline provisions. So every time I provision a new VPC or something to AWS with a new extension of the lab, it actually generates it and it updates all the information. Okay, so that's what's kind of happening on the back end here. So as soon as you log into Concourse, right, it's kind of like a pass-through authentication into the environment. So the next thing, what I'm going to do is I am going to run an automation task, and then we're going to reverse engineer it and compare that to doing it manually. So the first step is we're going to programmatically authenticate into Thousand Eyes. Now, initially, when you set this up in your own environment, you're going to go into Thousand Eyes. There's one manual step, sadly, and you go into users and roles. And then essentially what you would do is you set up a user. Let me go back here. Users and roles, users. So I have set up a user. So it's just a Gmail account for this lab. And essentially when you are working with the API, it has to have account owner access. So if I were to go to roles, this is where I assign all the roles. So if we look at this guy, oops, sorry, not that guy, this guy, that's your read-only, this guy here. So this is in an account group, and I have given this account group account owner role. So that's what the API uses. And then what I did was I updated in my vault the secret. So if I were to go here, I actually generated a token and I put it into my vault here. So that's the prep that I have done so far. There it is. Okay. So I'm going to run an automation task. My automation task is going to programmatically authenticate through to the API. And then it's going to make an API call. And then what we're going to do is we're going to reverse engineer it so that we understand all the steps in the automation. Then we're going to analyze the JSON payload, and then I'm going to use Jupyter Notebook to show you some techniques that you need to know for working with this payload. So once you're in this directory, if you do ls star .yaml, you will see that there's some task files in here. So the first task I'm going to run is this TE API task. So to run a task, and you guys can do this too if you want. You fly -t Cisco FSO labs. That's our target environment. E for execute, -c for config file, and the task name. Enter. What this is going to do, it's going to build an ephemeral build container. It's going to upload to the ephemeral build container this input directory with all these scripts. And then it's going to execute a Python script, which is going to authenticate through to the API and make an API call. So the first time this runs, it's going to take about 30 seconds to a minute, because what it's doing is every time I run an automation task, it's building me a fresh container, which is different from pipelining. In pipelining, it will assign a hash to the container and it will cache it, so it's much faster. But when we're doing this stage of development, it builds a new container for us each time. So it's going to stream the volume onto a worker and build my container. So while we're waiting for that to build, oh, it looks like it already built. Okay. So it already built. It was successful. I know it was successful because I got a 200 and I see my JSON here, a big blob of JSON. Okay, so let's reverse engineer this. What just happened here? So the first thing that happened, if we look at the task file, is that it went out and from Docker, it got my curated image, and disregard the name here, NetMiko, because this has nothing to do with NetMiko. But it's pulling down a Docker image that I have curated. And this Docker image has all the libraries. It has everything needed to build the code for Thousand Eyes. So you don't have to install anything local at all. You don't have to do any pip installs, nothing, right? Everything's on the container. Then what it's doing is it's using a parameter to pass in the ThousandEyes API token from the vault to the build container. So essentially, then it launches a shell script, TEAPISH, and this shell script is actually an opportunity for us to load anything additional that we want onto the build container. So I'm putting Python requests. And by the way, Python requests is the only module that we're using in this entire training to make our API call requests. So if you don't know Python, all you really need to know is Python request to use all of these APIs and JSON. And then it launches on my container, my Python. So, oh, actually I switched this to API challenge. Okay, hold on one second. I switched the script yesterday. Anyways, it's fine. Then it executes my script. So let's take a look at the script, TEAPI challenge. Where is it? TP API challenge. Here it is. No, where to go? TP. One second. This is really small. Oh, here it is. YAML TP API challenge. Okay. So it's running this script. So what this script is doing is it's importing some Python modules, which I think may be redundant. I'm not using all of these. I'm actually using request URL lib3. We're not using SSL just to simplify things. So I've disabled URL lib3 disable warnings. And then what I've done is here, it's saying token is equal to OS environment variable TE-auth token. So our automation in the back has passed in the ThousandEyes token as an environmental variable to our ephemeral build container. That's one way of doing it. Another way of doing it, which I'll show you later, is we actually use Python to make an API call to the vault to bring the token back. And so we're just using it within the context of that Python script. Then what it's doing is it's setting the API to the test API in ThousandEyes. And what it's going is getting that payload. And then we've written some code here to actually massage or work with the JSON payload to get for us all the agent to server tests. And then get out, I'm requesting that it get out my test name. And then I'm updating some metadata in the test. Okay, so that's what we just did. We did it really fast. And I'm going to show you that we can use this exact same script here to make any API call we want from ThousandEyes, and it will work. All we have to do is update our URL to the correct API. So how do we know what API URLs to use? Well, it's very easy. They're all documented up here on ThousandEyes. So if we go to ThousandEyes API, you can just Google it. It takes us to developer.thousandeyes.com. And in here, we can see all the different things that we can manage through the API. And so, for example, if we were to look at tests, it gives us the precise URL. It also gives us an example. And additionally, we can look up metadata for this particular API. Now, this was a little bit complicated. What we're going to do right now is we're all going to run the task, make sure everybody can run the task. And then what we're going to do is we're going to run the exact same thing, but in Jupyter Notebook. And the reason why we're going to do that is so that we can take a deeper analysis of the JSON and understand some techniques on how we can massage the JSON payload using Python to extract from it the key value pairs that we want in order to use those as input to our subsequent commands in our automation. All right, So I'm going to switch over actually to a more basic sample. So all I'm going to do is I'm going to change the script name in my task, and then I'm going to relaunch my build container. It's going to recopy up the code and execute the new script in my build container. All right, so let me pick one out here. I think, let's see here. Gonna arrow up. TAPI test vault, and this guy. See what I used yesterday. Okay, let's use agent server test.py. So I'm just going to update my task to run this script. Let me just see which one I used yesterday so I'm being consistent. One moment. Okay, didn't retain. So yeah, we'll use that one. TPA agent server test.py. Let me just quickly take a look at this one. Okay. All right, we'll run this one. Minus T, Cisco, FSO, labs, E minus C, and we're gonna do API vault task. Okay. So at this point in time, okay, so this one gave me a 400. Okay, so the reason for that is, let's just look at this. So I got an error, so that's fine. Let's look at the actual Python code and see what this code is doing. So we know that this part, right, is with the exception of the URL, we're going to be using these top 12 lines for all of our scripts. It gives us the proper modules and just imports the auth token. Now, in this particular script, we're calling the agents API. And what we're going to do is we're creating a test. Now, the reason why I got an error here is Thousand Eyes will not let you create two tests with the same name, obviously. So if we go into dashboards here and we go into Cloud Enterprise Agents test settings, we'll see that we already have a test named yourname.test, and there it is. So in this script, I was trying to create another test with the same name, and it gave me an error. So what I'm going to do is I'm going to just change it so that I'm making a unique test name. So let's like here, we'll call this test 101. Okay, and we're going to run it again. And the other thing that this script is doing is, after it's creating the test, it's adding all of our agents, so all of our enterprise agents, to that test. Okay, so we'll run it one more time and we'll refresh here, and it should create us a new test called test 101. And then it's going to add all the agents to the test. Okay, so let me go ahead and I'm going to run this again. And so at this point in time, I would like, and we got a 200, it succeeded. And we can see here that it added all of our enterprise agents to the test. So let's hit refresh and we should see our test in the console. So there it is, test 101. let's take a look at it. It actually added 4 of our 574. So it added, yeah, it added all of our enterprise agents to the test. So this is a bulk automation task. So I could have done this for 1,000, 2,000, 10,000 agents. It doesn't matter. The point of the fact is, right, is you can see the speed of bulk operations through the API. If you had to do this manually through the GUI, right, it would take a very long time. If you had 1,000 agents, it could take you days or weeks, right? So we do our automation of bulk operations and ThousandEyes through the API. All right, so at this point in time, I would like to give everybody a couple minutes to, after you have cloned the repo, checked out your branch, all you have to do is put test and your name, or you can even put your name, it doesn't matter. Go ahead and run the automation task, and then try running it again, and you'll get an error because you already have created the test. And once everybody has done that, what I'm going to show you is how you can update the test via the API and change some metadata. So on this advanced tab, you'll see that currently we only have perform MTU measurements checked off. What we're going to do is after you guys create your tests, I'm going to show you how you can make an API call to set some of these metadata options. And as well, what we're going to do is we're going to open up Jupyter Notebook, and we're going to go through this line by line to understand exactly what we need to do in Python to analyze our JSON data and extract from it the values that we need as input in the next steps of our automation. Now, one thing I want to point out here, that if we look at the API documentation for tests, so let's just bring this up. Hold on here. ThousandEyes API developer. If we were to go to the documentation here for tests, the test API, we will see that when we create a test via the API, we need a couple things. We need the test type and new. But when we update a test, oh, that's just to create the test. But to add agents to the test, if we scroll down here through the documentation, it will show us that we need to use the agent ID. Now, you can't get the agent ID through the GUI. It's not exposed. The only way you can get the agent ID is via the API. So before we can add agents to our test, we have to know what those agent IDs are. So the first step in our automation is we have to say, get us a list of all the enterprise agent IDs. Then we create our test and we add all of those agent IDs to the test. So there's a few steps in the automation. So I'm going to give you guys a few minutes here. And it is 9:54. This should actually only take you a minute. So at, let's say 9:56, I should, if everybody's participating, I should be able to hit refresh in a minute or two. And I should see everybody who is in this lab today, there should be a test with your name here. So please go ahead and create your tests.
Hey, Sherry,
Hey,
when
guys.
I'm trying, I'm getting a small error mapping YAML line 11. Value is not allowed in this context.
It's probably just, it's maybe just you. I don't know. Are you running this task? Did you update the task file to here? Hold on.
Okay, yeah, I think I must be gonna need to change the file, right?
Make sure, yeah, so check in TE
Maybe right.
API,
Yeah.
right? Because I just changed it. Make sure TE API is line 9, going to TE API agent server test PY.
Okay.
Okay. And then go ahead and open up TE API agent server test.py. And all you have to do is put your name, and then you can put test your name, or you can just put your name. Just make sure that you don't already have a test, you know, because you'll get a 404 if that test name already exists. So try running that, and if you get an error, we'll quickly have you share your screen. And if anybody else gets an error, please paste into the chat. Come on, you guys, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 people. We should have 10 tests here show up. So 9:56, we'll wait 1 more minute.
It worked. Thank you.
Perfect. Anoj test. Anoj made his. Okay. Everybody else? Is anybody stuck? I'm looking in the chat if anybody needs help. Okay. Don't worry. If you are stuck or you're not, you're having a problem with this, we will give you a little more time later. We're going to move on right now, and we're going to do this exact same thing, but locally via a Jupyter notebook. And the reason for this is to really teach you the Python that you need to understand techniques in order to negotiate JSON payloads from these APIs, right? So just so you know, I checked with senior developers at Cisco, senior Python developers. I've talked to senior developers in each of the BUs for these products. There is currently, the human brain has not invented any sort of AI application or other that will automatically negotiate JSON payloads from APIs. Now, there are some tools that may help you, like GraphQL, but at the end of the day, you must know Python to negotiate the API payloads. If you don't know Python, you could potentially use Ruby, Go, C, some other programming languages, but you will have to have some basic programming skills in order to negotiate the Python. Now, if you don't have any Python, you're going to learn today, and you only need to learn 2 modules, really. The JSON module and the request module. So I'm just going to quickly show you if you want to request module in Python. So the request module has a lot of documentation. It's very well documented, and advance. Oh, that's weird. Okay. Anyways, you can just Google Python requests. So, and this has all the documentation of everything it can do. The Python request module is specific for handling REST API calls. So I'm going to put if you want to research more about the request module, and then we're also using Python JSON module. This one. Okay. All right. So what I'm going to do now is open Jupyter Notebook, and I'm going to reverse engineer this entire script so everybody understands line by line by line what's going on here. All right. So to start Jupyter Notebook, I launch a terminal from my Mac. Hold on, oh, you know what? Hold on here. This WebEx is kind of interfering with my search bar. Okay, so I'll bring it up on a different screen here and drag it over. So Okay. This smaller. How do I, 1 second. It's, I'm trying to get my, okay, anyways, whatever. Let's, just open a new tab here and we'll type Jupyter Notebook. Jupyter Notebook. All right. Okay, so if you would like to follow along in Jupyter Notebook, you can as well. So once I'm in Jupyter Notebook, I'm going to go in to my directory because I want to save my notebook in my directory. So lab tasks, Thousand Eyes, TE API for Thousand Eyes API input. And I'm going to create a new Python 3 notebook. Okay. And I'm just going to copy in the first 12 lines of this script, paste them in here. Now, because we're going to play around with or negotiate some JSON locally, we obviously are not integrated with the vault. So you're going to comment out the line that says token OS get. And what I'm going to do is I'm going to generate a token for you. And then what you're going to do is I'm going to put the token in the chat. You're going to paste the token in here. And that's going to allow you to authenticate through to our lab Thousand Eyes API. So let me go ahead and grab a token for you. So I actually have one here. And by the way, you'll notice that my ephemeral build container tasks are printing everything out. The reason why they're doing that is because I actually specified in my task argument CEX. If I were to remove this X, we would not see everything. So when we're doing like development like this, and we want to see everything, we put X here. If we don't, then we remove it. So I'm just going to test this out. I'm pasting the token into the chat for everyone to use there. And then what I'm going to do is I'm going to test this, and I'm actually going to add in a line that says print agent response. So print agent response and run it. Okay, I got a 200 successful. So I'm successfully authenticated through now using this token, right? When we run the automation task, we don't need to do this. It passes it in automatically through the vault. All right, so now what we're going to do is we are going to set our test variable name to create a new test. So here I'm going to say test name, and we have one called 101. So I'm going to call this one, let's call it 120. And now that variable is set. So the first thing we're going to do is we are going to set our agent list JSON to our agent response.json. So we're going to put the API payload, we're going to dump it into a JSON blob. And now we're going to print out that JSON blob, and we're going to take a look at it. So we're going to do print agent underscore list underscore JSON. And now we're going to run this. And look at this. This is the payload that came back from the Thousand Eyes Agents API. We know that we only added 4 enterprise agents. So what is all this stuff? So the fact of the matter is that when we run an API call against the agents, it doesn't bring back just enterprise agents, it brings back all the agents. And we know that there are various types of agents in Thousand Eyes. Let's just see what they are. So we have the cloud agents that we know belong to Thousand Eyes itself. They're spread all over the internet. And we have our enterprise agents that we added here. We also can put agents directly onto URLs, which I have, and we can put endpoint agents onto our local machines. We're not going to do that in this lab because it would just be too chaotic with everybody installing it on their local machines. But you can install agents right on your local machine. You can incorporate it into your browser, and people do this for remote workers. So if they're having a lot of issues disconnecting from the network and so forth, they can do that to monitor the connectivity. So we're just using enterprise agents. So we got this massive JSON blob back. So before, right, we want to filter this out by enterprise agents. So the next thing what we're going to do then is we're going to say, how do I know how to do this? So I am setting my agent list to my blob, and I'm going to look for agents. How do I know? Because that's the first thing in the dictionary. And how do I know that this is a JSON dictionary? Well, what I can do is I can just say print type agent list.json, and it will tell me what I'm looking at. So we're going to do print type agent list.json. Okay, and if I scroll down to the bottom here, oh, actually, you know what? Let's put that at the top. That way we don't have to scroll through the blob. All right, so I can see at the top that this is a dictionary. But immediately I can look at it, I can say, oh, it's a dictionary, but guess what? There's lists in this dictionary, right? So, and there's obviously nested data in here, but all I care about is the enterprise agents. So what I do here is I set this to the first key in the dictionary. And then what I do is I know that I can see in this JSON blob that there's other dictionaries. Look here. List dictionary. So what I'm going to do is I'm going to say set my list of dictionaries to my agent list. Okay. Now, if I wanted to at this point, if I wanted to see how I'm doing with my JSON negotiation, I could say print list of dictionaries. Print, oh, I missed of. And let's see what it brings back for us now. Okay. This looks little different. You see this? It has converted everything to a list. So here we had a dictionary, and now we have a list. And if I wanted to verify that, I could say print type and see what this is, and it's going to tell me that it is a list. All right, so make sure I got all my brackets there correctly, and run. Class list. Okay, so now we're working with, we've massaged our data, we've kind of converted it. Now we're working with something easier to work with. We've changed it into a list of dictionaries. And now what we're going to do is in there, we're going to look for set our sought value to enterprise. So this is kind of like a filter. So let's go ahead here. We can remove these print statements for now. Then we're going to look for enterprise agents. And then what we're going to do is we're going to create an empty array. And then we're going to say, for our dictionary and list of dictionaries, if the dictionary is agent type enterprise, get the found values in that dictionary and print them. So I'm just going to copy this. I'm going to paste it in here. And let's see what it returns. Looking better, right? Now we just have the enterprise agents it's looking like. This is a much smaller, more manageable, right? We're whacking it down. We're negotiating our JSON. Okay, next step is we want to get the agent IDs, because what we're doing is we're creating a new test with the test name of 200 what did I set it to here, of 120. And then we're getting all the enterprise agents and we're adding it to that test. It's a bulk operation, right? It's a very common bulk operation. Another bulk operation would be to create a task with just a specific subset of agents, perhaps agents that have a prefix like dev or QA or stage or production, right? So for now, we're going to add all of our enterprise agents. So we only have 4. We're going to add them to our new test automatically. So to do that, right, what do we need? We read the API documentation already. We know that we need the agent, a list of agents. But what we don't know is what format the API wants us to submit that list of agents, right? Does it just want the IDs, or does it want us to submit them in a specific format? This is where you have to be able to read errors, because the API documentation will not tell you. This is where you have to use trial and error. And this is why you need to build your code in ephemeral build containers, because you need to rapidly iterate. When you're doing trial and error and you're massaging JSON, you're almost never going to get it right the first try, right? When I actually did this, it took me honestly about 20 tries, but I did the 20 tries in an hour. So I literally built 20 versions of a container in an hour just by arrowing up and making very discrete changes in my code. That's the DevOps rapid iteration methodology, and that's why you have to build your code in a container. The other reason why you need to build your code in a container is so that you can give that Docker file to anybody in the world, and you are guaranteed your code is going to work on that container, right? If I were to develop my code locally and I were to put it up on GitHub, the chances that that code would run on somebody else's machine are next to none, right? They would have to work on the, why? Because everybody's machine is different. People use Linux, Mac, Windows, they have different libraries, different security policies. So we never do local development code anymore unless we're playing around with something like this, like a JSON blob. The other reason for building your code in an ephemeral build container in a CI pipeline is because we don't want throwaway work, right? If we're going to spend the time to write some code, we want to make sure that our code is going to work in production. Wouldn't it be nice if the code that I wrote in dev always passed in production? Well, guess what? I know for a fact it will if I build my code in the same version of the build container that's running in production. So when we get into very large environments and we take all of our tasks and we build pipelines, we want the code that we write the first time would be nice in dev. It passes in dev, great. We execute it in QA, passes, great. It goes on to stage, the customer validates it, great. It goes into production, it's a success. Why? Because our build containers are identical across our environments, right? So I can't count how many companies I've been to in the past 20 years where production is down after they cut a new release of their infra code. Why? Because they did local development. So local development is a big no-no when we're looking at infrastructure in the cloud, infrastructure in hybrid environments, right? All right, so this lab is about workflow as well as the technology. So I digressed on the workflow. Let's get back to the technology. So we are working on this code here, and now we have all the agents, but we still need to massage our data. So what we're going to do here is we're going to create another empty list. And then we're going to say for an item in our found values, so this blob, which is our found values, where agent ID is equal to item agent ID, print the agent ID. And then I'm going to append to my empty list this dictionary format. Now, I'm not going to bore you with the details, but when I first tried to run this, I just passed the next API call, a list of agent IDs, and it failed, and it kicked me back an error, a Python error, telling me that I needed to send this data in a dictionary. Therefore, I had to write a line of code to create that dictionary format. So I can send my list of agent IDs in the proper required dictionary format back to the API. So again, this is why you need to know some Python, because that's not you're never going to find that kind of information in any documentation. You won't find that if you open a support case, right? Because we support the API, but not the code. So you need to be able to read the errors off the API and then massage your code. All right, so I already went through that experience. So I know now that this is what I have to do. So let's go ahead. And now that I've explained line 26 to 31, I'm just going to copy the whole thing in here and paste it and run it. And what this is going to do, it's going to give me not only a list of agent IDs, it's going to take that list and it's going to put them into a dictionary where the key value pair is equal to agent ID and then my agent ID value. So let's run this. Yay, it worked. So now what I have here, this is all my agent IDs, but this isn't good enough. If I tried to pass it like this through to the next API call, it would fail. You can try it yourself if you like. So what I have done is I've created this nice little dictionary here. And now I am going to use that to pass to the next set of calls. What it's going to do is it's going to add them all to my test that I've created. So I am going to increment this to 121 because I think I already actually created the 121 test, so or 120, so we're going to 121. And I'm going to go down here and I'm going to hit another API. This time the create new agent to server test, and it's going to add in my empty list, which actually isn't empty. I should have named it different. Okay, so let's go ahead and we'll copy this next part. And you'll notice that everything in this code is a variable with the exception of our test name, right? And the only reason why we're not automating this is because we want everybody to create a test with their own name so they can update it. So I'm going to go ahead and run this. And I got a 201, it says it's successful. Well, let's just validate it. So we should go into the GUI. The GUI should show us a test number 121, and it should have added all of our enterprise agent IDs. Let's go ahead here. Oh, I have to go in test view, one moment. Test settings. And yes, where's my test? Where's my test? 202, 120. There's 120. Oh, let me run it from the beginning to make the 121 test. So run, run, run. Run, run, and last one, run. Okay, let's go here. Let's hit refresh. Now we should have a test 121. Yes, there it is. And if we look, it has added for our 4 agents. If I go here and click enterprise, I can see. So it was successful. Okay. So we have stepped through some techniques for negotiating JSON. So let me highlight the techniques again. When we bring back our JSON blob, quite frequently it's impossible to know just by when it's very massive. So this is a simple one, but sometimes they're thousands and thousands of lines long, and they have nested dictionaries with lists, and each list has a nested dictionary, and the data becomes very complex to sort. And so one technique, of course, is to always do print type. So we did print type here, and we saw that we had dictionary. And then, of course, we just kind of look through our data and we know, oh, we got a list here, but look, there's another dictionary in the list. So we know we have nested data. So when we have complex nested data and we do print type, it tells us exactly what we're looking at. Another method is to, for filtering, again, is to pass our blob into a list. So we converted our data to a list, remember? And sometimes it's worthwhile to even flatten the list if it's a really massive list. And then we filtered out by type. We got our enterprise agents. So these are some techniques. And Jupyter Notebook, as you can see, is a very handy tool because we can change things on the fly and we can immediately see the output. Now, the only downside to this is, of course, we had to put a token in here. Now, once we have done this, all we need to do is to transfer the code, copy and paste it over, and run it in our container. So just because my code runs here doesn't mean it's going to run in a container. So we always want to make sure the code passes in a container. Now, I know for a fact that these two codes are identical, so I'm not going to test it again. So I'm going to look in here, and I'm going to refresh, and I think, okay, great. Oh, Anastasia, you got your test in here. Perfect. We have Anoj. If everybody else who is on this call can generate their tests, I'm going to wait for you another minute to generate your test via the API. And then if you don't, we're going to move on, and I'm going to show you how to update the metadata in a test you have created via the API. So going to have a little drink of water. It's 10:22, 10:24. Come on, guys, you can do it. All you have to do is change one line of code and run a command to make your test. It doesn't get any easier than this, so. I should see all the tests in here with your name on them. Crash? Okay. Well, it is possible that we do have some business individuals on the call who may just be attending to kind of get a high-level overview of what the capabilities are, and they may not be interested in writing code or running tasks. So we're going to move on. The next thing we're going to do is I am going to show you where you go in the API documentation to understand how to update your tests to change the metadata. So let's pick some metadata that we're gonna test. So we're gonna use sconrod test. That's one of my tests I created. And we're gonna go to the advanced tab, and we can currently see that when I created this task by default, the only metadata item selected in the data collection section was perform MTU measurements. But suppose I say, oh, that's not what I wanted. I wanted it to collect BGP data. I wanted it to perform bandwidth measurements. Oh, I want to update this. So how would I do this via the API? Well, the first thing I would do is try to figure out, usually in the GUI, the metadata name differs from what it actually is in the metadata, right? So in the metadata, there's probably no spaces, right? There's probably no upper and lower case. But in the GUI, they want to make it visually appealing, and so they will give it a friendly name. So let's go ahead and refer to our documentation and see for updating test, what metadata values are available for us to update. So let's go in to the Thousand Eyes documentation and let's click on updating a test. And we can see what the URL suffix is. So we need to provide it with the test type. We know what that is. It's an agent to server test that we're using. And we have to provide it with a test ID. Well, guess what? Again, there are no test IDs in the GUI. You can only get the test ID off the API. So we're going to have to make an API call to get our test IDs. And then it's update. So before we can update our tests, we have to get the test ID, which means we're going to have to negotiate the JSON some more to write our code to do that. And then we need to know what is the metadata. So if we scroll down here, the Thousand Eyes documentation has a hyperlink for each API. So we're selecting test metadata. And then under here, it gives us all the test types. So we're going to scroll down, and the agent to server test that we created is actually falling under network. And the reason for this is it used to be called a network test. At some point in time, they changed the name, but we can see here agent to server. So here's all the metadata fields, and indeed we can see that they're named slightly different than in the GUI. So for example, BGP monitors, if we were to look into the GUI, well, it doesn't say BGP monitors, does it? It says collect BGP data. So the documentation is never going to be one for one, right? Therefore, if you're not sure, the best thing to do, and that's another reason why we need to have ephemeral build containers, because we wouldn't want to do this on production, because at this point in time, we see there's a discrepancy between the GUI, what we understand to be perform MTU or collect BGP data, and what it's showing us in the metadata. So we're really not sure. We're going to have to do maybe some trial and error, some testing, but let's start out and let's write the code to get our test ID. And then because we are testing, we can play around with some different metadata settings via the API, and we can figure out, which ones match. Okay, so let's go ahead, and the good news is we can reuse most of our code. So once you kind of figure out the best way to negotiate, and there's various ways in Python, there's better ways of negotiating the code. This is kind of the most basic way, but there are other advanced techniques that I have seen, and you folks may know some as well. But to start out with, this is the most basic way. So we can reuse, obviously, this entire line 1 to 12, because this is just the programmatic authentication. So in my notebook, I am just going to actually use the same notebook. I'm just going to clear all this stuff out so I can reuse the top part. All right, and I can just clear this out. Now you can also save your notebook and create a new notebook. That's what I would recommend. So you have for your own notes, a separate notebook for each exercise. I'm just kind of recycling my notebook here. So I have my token set because I'm doing some local negotiation. And now what I'm going to do is we're going to change this URL to hit the test API. And I believe I actually did this yesterday on the fly, and I saved it here. So this is actually TE. We did this as a challenge yesterday, but I'm doing it as an exercise today. So we're just going to update the API to the test API. So all I have to do is replace this. And by the way, there's a better way of doing this, right? We could do URL prefix and URL suffix. That's pretty much what people do. And then all you do is you update the suffix, right? All right, so now we are querying the test API. And let's go ahead and run this again. Oh, and we got a 404, which means I think I need to generate a new token. The token probably expired. Is it test or tests? Oh, tests. No, sorry. Look at that. I missed an S. That's why. There we go. Our token is still good. I thought so. I thought it was good for a couple hours. By the way, when you're using the vault, you can rotate the token with every use, right? That's an option. So now let's go ahead and we are going to pass our agent response JSON blob that we get to our JSON Python module. And then let's just do a print test list JSON and see what it brings back. Okay. Brought back a lot of stuff. And again, it brought back a dictionary, kind of the same format as the last API. And in there we have a list. And inside that list, we have some more dictionaries. So we have nested data. And in this case, what I'm going to do is I'm just looking to update one test. Now, of course, a more realistic bulk operations scenario is we would be updating a whole bunch of tests, right? Like 100 or 200 or 1,000 or 20,000 all at once. But we're just gonna each exercise, each one of us, for those of you who created your test, you're gonna perform this exercise to now update your test with a metadata field of your choice. So we can see here when we're looking through our metadata, if I want to update the BGP and I'm not sure, and I don't really understand the documentation, or the documentation looks like it may be out of date, what I can just do is I can hit Control F, and let's just search on BGP in this blob and see if we can find, okay, so I can see there's a BGP measurements. Yeah, BGP measurements. So that's the actual metadata field, and I can see that it's either 0 or 1. So I'm gonna update, because I'm doing testing, I'm gonna update this BGP measurements. And then we'll execute the code, we'll look to the GUI and see which box it checked. So, all right, let's go ahead and we're gonna pass this blob into a list so it's easier to work with. Okay, and if I want, I can verify that it's now a list. I can do print test list. And before that, I can even do print type test list. Let's run this. All right, I've converted my JSON blob to a list. And I can see that it's got some nested dictionaries in there. So now I'm going to say my list of dictionaries is equal to that test list. And I am going to look for, if you remember, we already read the API documentation. It needs us to specify the type of list. So we're going to say sought value agent to server. And then we're going to create an empty array again. Oops, let me take that space out of there. And then we're going to say for those dictionaries, because we know by looking here that we have a list and it's got dictionaries. So it's a list of dictionaries. We know in our list of, we're going to, for the dictionary, in the list of dictionaries, if the dictionary type is agent to server, print those found values. So let's go ahead. This is filtering for just a type of test. So let's go ahead and we're just going to copy this whole blob here. Actually found values. Yeah. Copy, put in here. And let's run this. Okay. So we know for sure that everything in this blob is agent to server type of test. All right. Next step. We are going to put it to JSON, and then we are going to look for our test name equals to Conrad test, and then we're going to get that test ID. So let's do this part. All right, there's our test ID. So it's already set as a variable in our code. Now all we have to do is update our string with our test ID. Or if actually a better way of doing it would be to set it as just to put the variable here. But this is more of a conceptual situation. So I am going to update this. Oh, it is already 29478, okay. And I'm gonna run it. And I am going to set the, oh, that says bandwidth measurements. We said we were gonna do BGP. So let's do BGP measurements. And we're gonna put it to 1. And by the way, I'm just changing 1, right? You could change a whole bunch at once. So that would be an even better bulk operation scenario. And let's run this. Oh, it gave me a response 400. So again, I think I have to run this from the beginning. Run. And if you haven't noticed, doing this development on an ephemeral build container is not only more secure because you're integrated with Vault, but it's also much faster than doing it this way. So let's go ahead, run, and BGP update JSON, okay. Oh, give me a 400. Let me run it in my task. So to run in my task, drag this over. This is called TP API Challenge S Conrad. So what I'm going to do is I'm just going to run it in my container. I am going to select my task. So TE API Task Vault. And I'm just going to update the shell script it calls with the name of this Python script. So copy path. Where's my shell script? There it is. So I'm just going to update it here. All right. And now I'm going to run my task. So hopefully this will succeed. And if this succeeds, I would, yes, 200 it did. So now let's refresh the GUI. I must have had a typo or something in my Jupyter notebook. Let's refresh our GUI. And we should see that one of these is now set. Probably it's going to be this one, I'm thinking. Let's Conrad test. Nope, it didn't. Did I up? Hold on. Let me check my script. Did I pick the right tests here? Test ID. Yep. Okay. So that was not the correct metadata. Yeah. So let's pick another one. So let's go back to our JSON blog. Let's try bandwidth measurements. Oh, you know what? I didn't update it here. Hold on, let me try that again. My bad, sorry. BGP measurements. So BGP measurements and then 1. Let's run it again. So can everybody see the benefit of running it in tasks? You see how much faster it is, right? All I have to do is rebuild my container. Still set of 400. So something is wrong here. Let me just quickly debug. So I got a 200 before. HP measurements 1. So maybe the GUI is just slow to update. That's another thing too. It could take a while for. Oh, I'm seeing more. Swati has another test in here. Great. Seeing some more tests come in. Just pick my test. All right. Let's try, instead of BGP measurements, let's try network bandwidth measurements. So network measurements. Oh, network, let's see, bandwidth. And, oh, bandwidth measure. Bandwidth. Okay. So bandwidth, let's try the bandwidth measurements and let's change it to 1. I believe it's not selected. Let's see what happens with this. Go over to So 200, it said it succeeded. And let's pick my test. Ah, yes, it succeeded. You see that? The box is checked, whereas it wasn't before. So in this manner of rapid iteration, we can very quickly use trial and error in order to know precisely which, when we change a metadata in our code, what it's going to look like in the GUI and so forth. So at this point in time, I challenge everybody to pick out a metadata value of your choice and run the automation, run the task to update the test that you created. Now, if you remember, if you're using the same task, right, TE-API task of Vault, you don't actually make the change in the task itself, right? You're going to make the change in the shell script that the task launches, which is this TE-API shell. And all you're going to do is update the name of the script. And of course, what I recommend is you make it, because you're working in your own Git branch, just make a copy of my script. And then what you can do is you can, and name it with your name, obviously. And then what you can do is just update the test, the filter here to match the name of the test you created. Okay, so what it's going to do is it's going to go out and it's going to filter the JSON blob off the API for the name of your test. It's going to get the test ID of your test, and then it's going to update that test ID. Oh, you also have to update the test ID here. And then you run your task. Oh, you also have to update whichever metadata value of your choice. Just go ahead and pick one. And run it twice. Run it so that you get a pass and a fail, or a fail and a pass. And I'll give everybody, it is 10:42. This is a very easy challenge. So I'm going to give you until 10:45. It's 10:42 right now. And I'm going to actually get a drink of water and come back. And hopefully everybody will have ran the automation code to update their task. If you don't want to run it in the ephemeral build container automation CI pipeline tool, you can also run it in, because you have the token now, you can run it in your favorite IDE or in the Jupyter notebook. So if you prefer to do it manually and in the container, you can do both, right? All right, we'll talk to you guys in 10:45. I'm gonna pause the recording. Okay, guys. So let me review. What have we learned so far? All right. We had a very high level overview of the Thousand Eyes GUI, enough to set up your API key, understand what a test is, understand that Thousand Eyes is a network monitoring tool. It can give you insight into the underlay, even core routers and switches on the internet. You learn how to automatically and programmatically authenticate via code to the Thousand Eyes API. And those Python scripts that are in the repo will work anywhere. So you can take them with you. You can use them in your own environment. You can call them from your CI tool if you're using Jenkins or whatever you're using, right? I will give you a repo link where the Docker files are, so you don't have to rebuild the Docker files. Actually, let me do that right now. All right. So in this repo here, these are the curated Docker files. Swati, I'm doing it all again. It's fun. Yeah, it's fun. Once you get used to it, it's like the fastest way to build your code. So, anyways, in this Docker builds directory, there are multiple branches. And if you look in your task file, it will tell you which Docker file it's using. So for example, let's go ahead and look at Thousand Eyes. Let's look at that one. So in this branch, this is the Docker file that Concourse is building your ephemeral build container that's building your code. So as you can see, it has all the proper version of Python, blah blah blah. It's got I've added some additional tools on here like jQuery, Telnet, OpenSSL, whatever. It's got everything that you need to run, build, develop, start developing your own code to the Thousand Eyes API. And then there's also one for, well, I got a bunch of them here. Hold on. Yeah. And these images are actually also up in Docker Hub, and I believe that they are public, so you can pull them right off of Docker Hub. How would you know how to do that? You just have to look in the task files for each exercise. So in this task file, it tells you right at the top that this is a platform Linux, it's a Docker image, and the repository is sconrad netmiko. Okay. So that's how you would know where to pull. You could pull this right down from Docker if you wanted. All right. So we have automated the creating of a Thousand Eyes test and adding all the enterprise agents to the task. We have experience now, hands-on experience with automation of updating the metadata for the test via the API. And we have compared manual code development using Jupyter Notebook and hard coding our authentication, which is not a best practice, with building our code in ephemeral build containers. And we can see that it's much faster and it's much more consistent. And that's what we're going to be doing going forward in this lab. So we're at this point in time, we're going to stop doing local development because we have hopefully established the fact that local development is not the way to go. So we're just going to be building our code on containers from this point forward. And that's what we've learned so far. I'm going to just give one more swipe over the Thousand Eyes GUI, and then we're going to move on to the App Dynamics API. And before we do that, people can vote if they need a bio break in the chat. So please indicate yes or no if you would like a bio break in the chat. If not, I'm just going to keep blasting forward with the app dynamics. So I'm looking at the chat. I'm not seeing that anybody needs a bio break. All right. So to close out Thousand Eyes. So by the way, with this methodology that you have just learned on working with the Thousand Eyes API, you can do anything in the Thousand Eyes API. All you have to do is look at the developer doc, get the URL, and figure out exactly what you need and build it into your code, how to negotiate the JSON, and what are the Python best practices. All right, so let's go ahead and let's just take a little bit more of a look at the dashboard here before we close this out. And I also have a test. You can also set up tests for Amazon regions. So I have a test set up here for the region where the infrastructure is running the lab, so the concourse and the vault and everything. And I can drill down here. So if there's ever an outage, and by the way, there was one back, I think it was in February, there was an outage. This region, or an availability zone in this region went down. And I can drill down here, and I can even see BGP route visualization. Now, in my opinion, this is the real value of Thousand Eyes, because there's no other product on the market where you can see the internet underlay. So this is actually out on the internet. And I can see that to get to my agent here, here's the agent here, on Amazon in this region, right? These are all the routers or switches and the providers. We can have NTT, France Telecom. We can see all the paths, right, to the cloud agents in all the different countries. So we can know if somewhere like there's a core router down. So how many times in the last 6 months have you come into work and you've realized there's been some sort of like AWS or cloud provider specific availability zone? Something's been down, right? There's been a lot of them. You can just check the news, right? You can instantly come into Thousand Eyes and you'd be able to see what it is. So you can even drill down here. So if I wanted to go into France Telecom, Backbone, and this is managed by Orange Worldwide, it's an AS 555. So if this was down, right, it would show me down. And now I can show routes only going through this router. So this is the real value of Thousand Eyes, right? This can save you a lot of money on an outage. If you're in California, there's a lot of power outages, brownouts, right? So you may be a telco, you may have, I don't know, you may have 200 sites in California, customers that you're managing their infrastructure in their data center, whatever. There's a brownout. You can immediately come in here and you have your test set up. You can immediately see what's down, and then you can take remedial steps. You know, you can change routes, or you can take what actions are necessary to mitigate the situation, right? All right, so enough of Thousand Eyes. We have a lot of GUI-based training on Thousand Eyes. If you would like a more detailed GUI-based training, please reach out to me. I can either provide you links, videos, or let you know when we have like the advanced GUI training sessions. I'm just handling the API today. So we're done with Thousand Eyes. Let's go ahead and move on to App Dynamics. Now, App Dynamics is much more complex in my opinion. So for App Dynamics, I'm gonna have to give you a little bit of a background. Now we are using, I'm gonna close out of Thousand Eyes here. And we're not doing Intersight quite yet. Let me log into App Dynamics. So this is the SaaS-based App Dynamics. It's not the App Dynamics Cloud. It's still the SaaS-based. So I'm gonna just log in here. So there is a very new, almost beta, emerging version of App Dynamics Cloud. This environment is the SaaS version of App Dynamics. And so the controller is managed by App Dynamics. It's up in the cloud. So this is the App Dynamics console. Now I could probably spend a day, like a whole day, just on the App Dynamics GUI. So we're not going to do that. What I'm going to show you is that, now let me give you an overview of App Dynamics. App Dynamics started out as a monitoring application for Java apps. And that's still what it does best. App Dynamics has now added in additional capabilities to monitor, alert, and collect metrics for a variety of databases, Kubernetes clusters, different types of services, as well as it has an open telemetry option. They've also built in alert and respond. So today, we couldn't possibly cover all of these features. So what we have done is I've set up a couple things here, what I thought were the most common use cases. So one is a cluster agent, which monitors Kubernetes clusters. This cluster is the Kubernetes cluster running our underlying lab infrastructure. So it is actually running the concourse, the vault, and in addition, I've deployed some other apps, and that's this cluster. So as I'm running the lab, if we start to see a high workload on, for example, Concourse, I can look in here and kind of see if I need to scale up or scale down. All right. As well, I have another cluster. This cluster is just running Helm chart apps. So it's running like RabbitMQ, Rocket Chat, a bunch of different things. So I can come in here and I can look at the pods. I can look at the namespaces. So I can see I have Supercar Eraser, RabbitMQ. Oh, actually, I think I removed Rocket Chat. And it gives me an inventory. It gives me some performance statistics in regards to RAM, CPU, disk. It tells me if I have failing pods, etc. And there's no events going on. Oh, there are some events actually. So, and it shows me some events that are happening on the cluster and any errors. Okay, that's interesting. Actually, I'm gonna take a screenshot of that one. It will also bring in logs. Okay, so we have that. And then as well, I've also set up an application. This is a Java app, and the Java app is here, Supercar Trader. Now, because this app, I have this app, so this webpage actually is, I've locked it down so it's only accessible from my IP address because this app has some built-in exploits. And I believe it has log4j. So I didn't want to expose it to everybody, but it's enough for you guys to know it exists. And I'm going to click around on it a bit. So it fires up some JVMs here. And later on, I think I'm going to load balance, or I'll fire some load at this, generate some load. But in the meantime, you can see that this Supercar Trader Java app is running actually in two places, on an EC2 instance and a Kubernetes cluster. This one here is on an EC2 instance. And in order to have App Dynamics connect to it, I installed an agent, App Dynamics server agent, and I made a change to the catalina.sh file so that it will report in everything that pertains to Java into the App Dynamics GUI. Now you can see this is really nice. It shows me all the Java nodes and it shows me the flow of the business transactions. I also have a couple SQL databases that this Java app connects to, and it even goes out and connects to some like microservices or external applications, Progressive for insurance node, Geico, Rate Kick, and also fuel economy. So these arrows, I can hover, it shows me the transaction flow. This application is really great for Java developers who want to, they can have this set up against all their environments. It can help them build more performant applications. It can show them when, for example, say Progressive was down, they would instantly be able to see that. It shows if there is any latency, slow SQL queries. I can drill down into the database here, view and database visibility. And it can show me that everything's normal here right now. And if I had any long running SQL queries, it would show me, it's showing me CPU, memory utilization, disk IO. So it has a very rich, comprehensive, detailed GUI. There is a lot we can do with the API. Now, the nice thing about this API is this API, I believe is a Swagger open API standard. So the JSON that it returns for us from the payload is much easier to read than in Thousand Eyes. Here's the activity of my Supercar Racer app. So as you can see, I can go on top activity, time comparison, query read state. Is very detailed, right? So this is like Java developer heaven. Now, why do network administrators care about this? Well, how many of you have been called in the middle of the night by the knock saying, our app is down, our bread and butter app, right? Our shopping cart or whatever, our e-commerce app is down. And it's a network issue. So you're the network guy, you get on the call and you're like, nope, it's not the network guys, it's your app. And they don't believe you. They say, no, look, my app can't connect from here to here. Well, you can go in here and you can show them, well, look, you have this slow running SQL query that's chewing up, all the resources on your database, and your app is like cacking because it can't read and write from the database. So someone's got to log in a SQL database and kill that long running query, right? So in that case, right, this is a tool both for Java developers, but also for network operations and also for DevOps. Because in many cases, the networking team has zero skills in regards to Java apps, and they're not supposed to, right? They're responsible for the network. So you need something to kind of help triage these and prevent these instances. So if you have some sort of e-commerce app and you have like a buy one, get one free, and suddenly your Java app starts slowing down, you can come into this app and you can pinpoint the actual business transaction. And then what you can do is you can view top queries. So this is showing me the actual SQL query. So I can get to the root cause of the issue really fast, and then I can make the changes that I need to mitigate the issue and hopefully get my app back up online so my customers can keep buying my stuff, right? All right, so I've given you a very high level of this GUI. Obviously, we have GUI trainings on this that are like 3 hours or longer. They're incredibly in depth. I'm going to skip right over to the API. So before we can start doing anything with the API, we have to authenticate, right? Forget everything you just, or not, put everything you just learned about the Thousand Eyes API into a vault in your brain. And this is a completely different API. It's developed by a different business. Cisco bought these companies. Cisco bought Thousand Eyes. Cisco bought AppDynamics. So they're separate companies, separate APIs. Authentication method is completely different. And the JSON, everything that you need to know is completely different. So the first step, we come into settings, we go into administration, and I've already done this. We go to API clients. Oh, and by the way, you guys can use the same account that I gave you for Thousand Eyes to log into this GUI. And I think you have a lot more access, so please don't do anything destructive. Under API clients, I have added the same. And now on this one, what I have done, and I'm going to do it again, is what you need to do is generate secret, copy, and save. Then you need to go to your vault, and here we have aptd helm. Oh, is it aptd helm or aptd? Yeah, it's aptd secret. aptd secret. Okay, I'm going to edit my secret, update it. And by the way, you can base 64 these values in the vault. So for example, that one I haven't base 64, but my aptd helm values file, oh, actually, okay, it's blank right now. I haven't aptd helm values, hold on. No, blank. Okay, some of my config files and so forth, I've actually base 64 encoded them. So if you click on them, right, you won't be able to tell what they are. I just thought I would mention that. All right, so I have updated my aptd secret. So the next thing what I'm going to do is we're going to switch over and you guys can follow along with me. I'm going to close out all this stuff from Thousand Eyes and we're going to switch directories into our AppDynamics. So from the root of the Git repo, you're going to go into lab tasks, AppDynamics, aptd API, auth, input. Okay. So I'm going to switch into this directory, copy path reference, absolute path. I'm going to come down here, CD into that path. All right, and I'm going to do ls star.yaml to see what my task files are. And I have 3 tasks in here. But the first one we're going to do, and I've split the authentication tasks out into 2 in order that I really clearly communicate that they're, whereas in Thousand Eyes, there was 1 step to programmatically authenticate. In App Dynamics, there's 2 separate steps to programmatically authenticate. So the first one is to authenticate to the vault via the secret, and then it is to generate a temporary OAuth token, write it to the vault, and then we call that token when we're executing our API commands. So 2 steps, we're going to run them separately, and then we can combine them into one, or we can, we could create a module for each and just import the modules into Python. But for learning purposes now, we want to highlight these steps. So I'm going to go ahead and I'm going to run my first task, which is apt get token task, and then we'll reverse engineer it. So again, let's fly -t, target Cisco FSO labs, which is the name of the environment. And then we're going to do E execute -c our config file and enter. All right. It's going to, and by the way, you guys, you can also, when your task, if you want to multitask, is you can, it actually gives you like a view here. Let me log in. Oh, US, what did I give you? US East, right? US East, I can't remember. 1A, US hyphen East 1A bang. Is it West? I can't, okay, well anyways. Whatever credential I gave you, you can log in here with it. So hold on.
US East 2A, not 1A.
Oh, what was it? Okay. US East 2A. US East 2A bang. Right. So you actually have a GUI view of your task as well here if you want. And this is nice when you're multitasking. So if you have a really long task, and also you can see here, I'll just quickly show you this. We're not going to get into pipelining today, but there's a bunch of pipelines in here. These pipelines I use to orchestrate and automate the actual lab deployment into the cloud. And what these are, when you build, this is a very simple pipeline. The reason why we're starting out with tasks are the most basic building block of a pipeline. When we are running pipeline jobs are made up of many tasks, multiple tasks. And what we can do is we can pass input and output between tasks, but not jobs. If we want to pass input and output between jobs, we have to use an artifactory. That's why I'm using the Vault. It gives me the freedom of generating values and then using them in anywhere I want in my pipeline. Now, at the end of this API training, I can spend a little bit of time if people are interested on how to build pipelines from tasks. So we build pipelines to orchestrate and automate our entire infrastructure. So for example, we can use the pipeline to not only auto deploy and provision our entire AWS environment, which is what this does here, but when that's done, it writes all the objects that we've created into the vault. And then what we can do is we can execute subsequent pipeline jobs that use those values to do things like deploy instances, deploy VLANs, deploy CSR routers and configure them, to deploy all the agents, to configure them, to do whatever we want, right? Anything that we can do in an automation task, we can add it into our pipeline. And since everything is using variables and it's using the Vault as an artifactory and Docker as an artifactory, we can fully, anything that is infrastructure as code, we can fully automate it through the pipeline, all of it. So this is a very simple pipeline because it's just putting a cloud environment. But anyways, the point that I was making here is that you have two views, right? You can watch your task in the GUI if you want, but it's just another GUI window. You're going to see the exact same output in your IDE. Okay, so it ran. I got a 204, and oh wait, and there's a little error at the end here. I think we can disregard this error. Now, another thing I can do is I can intercept onto my container by just doing intercept. Now oh, wait, I think my, oh no, I spelled it wrong, intercept. Okay, so now I'm actually on my build container. So I can, it's just like its own little, you know, it's like it's its own computer. You can see it has a file system here. We can do cat, etc, os, release. We can see it's a little Ubuntu container. And we can even, if we do an ls, we can see that it copied up our entire input directory with all our code. Now, again, why would we intercept a container? Well, I intercept my containers from time to time when I'm debugging, but most of the time I don't have to. In production environments, sometimes what can happen is if you have Java developers, they'll just keep dumping more and more and more code and more files. They don't really understand that these containers have a space limit. So on this one, we can see that our container has, you know, it actually has a 20 gigs of space, right? And our overlay is using up 40% of it. So that's the only time really in like the real world when I have had to intercept onto a container and just check like the free space and the memory and stuff. And then, you know, I can get back to the Java developer and I can say, hey, you know what, clean up this stuff out of your deployment. And usually they do. It's very rare that we would increase the size of the overlay to more than 20 gigs. I mean, I've never had to. And these are faster the fewer layers in your Docker build. So when you're building your Docker files to use for your ephemeral build containers, you want as few layers as possible. So I think you notice when I exec onto the container, let me get off again. It actually has 3, it says pick one. Oh no, it didn't. Okay, it only has 1. But sometimes you go on and they'll have like 3, 4, 5. Those are all the different layers, right? So anyways, I'm gonna get off the container now. Because the container was successful, it's going to disappear. It'll be automatically garbage collected because it didn't really throw an execution error. All right, so let's go ahead now. And I am going to actually, so CEX, okay. This guy is running apt-get token.sh. Let's take a look at the script. Again, it's making actually a Vault CLI command call to get the apt secret out of the vault. It's passing it into an environmental variable. I think I mentioned this is one way of doing it. A more secure way is to actually make the API call to the vault through the Python script, right? So anyways, this one is running get apt token.py. So let's take a look at the script. And in here, again, this is just the Python modules we're using. They're basically the same. We're disabling any URL-lib3 warnings, and we're importing request module. Request is what we're going to actually use to make the API calls. And in this case, then, we are going to be calling the OAuth token API. And our payload, how did I figure out what this string was? With a lot of pain, guys. They don't just give it to you. You can't Google it. You have to actually go to the documentation, and I'll show you. If you go to App Dynamics, API, they have some very kind of nebulous and fuzzy documentation on how to formulate this string. To be perfectly honest, it was just a lot of trial and error. I think I had to do about 5 or 6 tries before I actually got the correct format. This here is obviously my account. And if you look here, they have a lot of documentation, and anyways, it's not explicitly stated anywhere. So this is work that I have saved you, probably 3 hours of work. So you don't have to figure it out. It's already figured out. And then I'm just appending the secret value. Okay, so that posts, and then I bring back a token.json is equal to the response. So now I have my token in JSON format, called it out of the vault. Here, this is some throwaway code. I was just writing it out to a file on my container, and I can show you that in a second. I'll run it again to intercept the container. And then what it's doing is it is actually going through using the temporary, getting the temporary token here. And here, I am actually calling the Vault API using requests again. Okay, so it gets that temporary OAuth token, and then we use that token to execute our API call. So let's go ahead and look at the next task that we're going to run. So if we do ls*.yaml, ls*.yaml, the next one is going to be use token. So before we run use token, let's just take a look at it. Use token task is calling the app-to-use token shell, which is calling the app-to-use token py. Let's take a look at that app-to-token py. Here it is. Okay, so yesterday we were playing around with a whole bunch of different API URLs. So we're gonna start out and we're gonna use the temporary token that we just generated that was automatically written to our vault. We're gonna call it out of our vault, and then we're gonna use it to execute a API call. And I'm kind of concerned why I have this huge gap here in my code. It's almost like, anyways, let me just look at something may have got screwed up here. Just hold on. Let me look at my local history, show history. Just scroll through my history to make sure I'm not missing. No, it looks good. Okay, so let's go ahead and run this. And what it is going to do is it's going to execute against this API. It's going to get us a list of all the App Dynamics beta agent versions. So I'm going to go ahead and run this task. So I can actually just backspace and update task name. Okay, if I wanted to, I could click on that thing. Okay, so it ran, it was successful. And again, if I wanted to look at it in the GUI, it looks like this, right? So anyways, so there, it brought us back. Now you can see that the JSON payload that it has returned for us is a much nicer format because this is based off of Swagger Open API standard. It's not as complex. What type of JSON do we have here? We have dictionary, right? And in the dictionary, for some of the key value pairs, there's also a list with another dictionary. So it's nested, but it's not near as complex of a format as Thousand Eyes. So now I'm set up to run any API call now, any API call at all. So let's go ahead and look at what some of the things are that I can look at. Well, let's look at business transactions. Let's go back to our supercar. I'm going to click around, get some stuff going. Maybe if I get inspired here after the lunch break, which is coming up, I will fire up the load generator tool and blast some load on here so we can get some more meaningful, hopefully some more complex nested business transaction JSON to play around with and negotiate. All right, so I've clicked around on my app, so theoretically, right, I should have generated some activity. And if we go, close down this Thousand Eyes. If we go to App Dynamics Developer, we see, oh, business transactions is something that we can look at. So let's figure out what we need to do to get the business transactions off the API. So we're going to find the string, retrieve all business transactions. Well, first of all, let's retrieve our list of business applications. And then let's go ahead and retrieve all business transactions in a business application. Now, this could potentially come in very handy as opposed to looking in the GUI. As you know, a lot of companies may be running, 10, 20, 30, 40, 50, 100, 200, 500 different apps, right? Maybe you don't want to have to flick around in the GUI to find what transactions are slow for a particular application. Maybe you want to write an automation task or have your pipeline report on your bread and butter application on a regular interval. Maybe you want to pull off those transactional JSON and ingest them into some sort of other analytics tool, right? The world is your oyster. Once you have the data, you can do anything with it you want. You can even ingest it into a big data warehouse, send it to Splunk, whatever, right? So let's go ahead and let's retrieve all the business applications. So let's see what the documentation is telling us here. Well, giving me an example and is saying that if I want to just get all the applications, this is what I need to do. I have to run a get on here. So let's do it. So let's go over to our code. And what we can do is we can comment out this guy. And we're just gonna formulate our string. And we're gonna take everything. This is the prefix here. So we're gonna do URL. Okay, so that looks good. So that's our URL. And let's go ahead and we're just gonna run it. And it should bring back for us all of our business app. Oh, wait, something's wrong. I think I have to do question mark output equals JSON. So you see they're missing in their documentation that. So anyways, let's run it again. And this, again, we're doing rapid iteration, right? First time we ran it, it failed. We knew right away our code failed. And in fact, if you talk to developers always write their code to fail first, right? We want our code to fail. And then, I know it sounds weird, but then we write it to pass because we need to, anyways, that's part of the rapid iteration, agile, NetOps, DevOps, developer workflow is write the code to fail, get the error, make the change, write it to pass. Because we're using ephemeral build containers, we can do it extremely rapidly. All I had to do was arrow up and make one change to my code, right? Now, all this code is in my local repo. Once I get all the code the way I want and I'm happy with it, right? At the end of the day, what do? I always do? I always commit it. Always, always. So depending on what you're working on, I usually commit my code every hour. Some people like to commit it at the end of the day, but you should at least be committing your code once a day so, a disaster doesn't happen and you lose everything. So what do? End of the week, end of the sprint, you have to get your PR in. You've tested out all your code. You've added your commits. What do? That's when you build your code in the pipeline. Code passes in the dev pipeline. That's when you put in your PR. That's when your coding peer reviews it, maybe kicks it back to you and says, pepate your Python code. Split this URL. We want to have a prefix and we want to have a suffix. Put a index or whatever. And then you'll iterate on it, you'll fix it, and you'll resubmit it for PR. Hopefully that time your coding peer will accept your code. And because it's already built in dev, it will get into hopefully with all the other developers, it will get into consideration for release. And that's when they will take all the code from all the developers and they'll build it in the next pipeline. So you may have built in test, they'll build it in dev. If it passes in dev, that's the release candidate. They'll semantic release it and they'll allow it to build in QA. QA is where the regression testing happens usually. And sometimes that's when the other pipelines will kick off, building the bread and butter apps that sit on top of the infrastructure layer. If those all pass, then you have a production release. So it gets scheduled, it gets a semantic release, and hopefully it gets sent out to production. All right, so let's build this task again. And this time we are calling, oh, we already built it actually. So it brought back our one app. So we only have one app and it brought back the ID, something we can't get in the GUI, something that we need now to get all the business transactions. So let's go ahead and let's get all the transactions for this app. So how would we do that? Again, we go back here, business transactions, okay, and retrieve all business transactions in a business application. And it gives us the link here. And oh, how nice. We actually can just use the name. We don't need to use the ID. So that's a step up from the Thousand Eyes API. So let's go ahead and we're going to take everything after REST. Go in here. Let's comment this guy out. Let's take the prefix from REST backwards. Oh, actually from URL backwards. Yep, here. There we go. All right, looks good. And we have to put our application name in here. So this is going to be Supercar Trader. And there may not be a lot of business transactions. So on the launch break, what I'm going to do is I'm going to, I have a tool that fires load at this guy. So I will run it. So let's go ahead and rerun now. And this should bring us back all the business transactions. Oh, what did I forget? I forgot something. I forgot my quotes. That's okay, right? Very rarely does anybody ever write code that passes the first time. So let's rerun it. Boom. Okay, it brought us back something, but look at the format. That does not look like JSON to me. So what do we need to do? We need to append question mark output equals JSON. Let's rerun it and it should bring us back the same information but in JSON format. And it did. Right? So here's all the transaction data. Much nicer. Okay, folks, at this point in time, I'm going to propose a challenge to you. Please go ahead, run the task, pick out from the documentation any API you're interested in. I would recommend you do one to do with business applications or Kubernetes cluster or SQL database. So those ones, we definitely have data. They should definitely return from you a response. Please log in to the App Dynamics console with the credential I gave you so that you can run API calls. You can, change some metadata, and then you can see your results in the GUI. So let me just give you that credential again. It's the same one as that we used for 1,000 Eyes, and just put it into the chat here for you. Okay, so I'm actually gonna test that this works right now. So when we go to we're logging on to the SaaS controller. So the SaaS controller link is this. And I'm gonna do an incognito window because I'm already logged in. So this is the URL. Let me put that in the chat. Okay. And then account should be, the account is also actually going to be that. And then the username is going to be this, I believe. Password. Okay, I'll tell you what, you don't have to have access to I gotta fix up some permissions here with this account, but you don't need to be in the console to run this automation task. So, please go ahead. Now, if there's anybody that would like to run it locally, you can do that as well, but you're gonna have to need an OAuth token. So let me show you a trick. To get the OAuth token, what do we need to do? You would need to run the get token task. And, okay, good, it's at CEX. It should print out the token for you. So let's just verify. So I'm gonna just rerun this task to pull the OAuth token out of the vault. Oh, actually, it will be, I think it's this one. Let me run this one and let me just, yeah. Token. Let me just make sure that CEX, okay. So what we can actually do here is we can see hold on here. Yeah, actually what you could just do to get it is you could just add a line here that says print string OAuth token. And then you can run this task and it will print out your OAuth token. And then you can copy and paste it into Jupyter Notebook if you so like. So that's how you would actually get the token. Okay, so anyways, I encourage you to use the tasks. So at this point in time, it is 10:38. Let's take a 20-minute break so everybody can have like a bio break and go eat a snack or some food. We'll start back in 22 minutes at 12 p.m. We are going to finish up on the apt API, and when you come back, I will have I should be firing load at it. So we'll have some more interesting data to query. And then I will be moving on to the Intersite API. And the good news about the Intersite API is, although it is a much more extensive API, it is written to Swagger as well. So the JSON we get back from it is in a very nice format, and it is very easy for us to negotiate that JSON in order to pull out MOIDs and so forth. Okay, so you guys go get some food, take a bio break, and we'll see you back in 20 minutes.
Sherry, you want to stop recording?
Yeah. Okay, so this, we can see that it has returned for us a nice list of dictionaries. These are all the business transactions. So at this point in time, I decided that not to fire load at because it's really not going to give us any different JSON format. So at this point in time, we're going to move on to Intersite. And I discovered a hack for Intersite. So let's all I'm going to log into the Intersite console now. We're going to close out the App Dynamics API. I'm going to switch directories into Intersite. So from your IDE, if you're browsing there, it will be lab tasks, Intersite API auth, and input directory. So we're going to change into this directory. Pardon me. And we're going to do ls*.yaml to see what tasks we have in here. So we just have one. And I'm going to close out the appd Supercar Trader app. And I'm going to log into Intersite. Now, Intersite, you guys get a 30-day eval for free. You just need to sign up for a Cisco account. And the only thing is you won't have IWO. Now, the component of Intersite that is part of the FSO stack is the IWO. That is the Intersite Workload Orchestrator. So right now I'm going to give you a very high level overview of what that is, how it looks in the GUI, and then we're going to switch over to the API, and we're going to learn how to programmatically authenticate to Intersite, which is totally different than the last two APIs. And we're also going to learn how we need to post to the Intersite API. We have to provide MOIDs, which is a little bit different because the Intersite as well incorporates hardware. And by the way, I'm going to teach you a hack here. All the code to auto deploy, auto instrument this entire lab, everything, the apps, everything is in the Git repo. If you decide to do it into your own AWS account and you don't have the hardware, I learned a hack here. So I wasn't granted any budget for hardware, believe it or not, at Cisco for this lab. So in order to plug hardware into my lab, I just hijacked it off of the Sandbox labs. So what you can literally do is you can literally spin up a bunch of sandboxes for free, and you can target them right into your Intersite. There's no firewall issues, which is what I'm doing with UCS, because I didn't have a hardware server in my lab. So I'll show you how I do that as well. And it doesn't cost you any money. It's completely free. So, all right. So the first thing when we log in Intersite, when we are integrating Intersite, let me make this bigger, with App Dynamics, what we do, or with any hardware or cloud, is we set a target. So right now I have two targets. I have Amazon Web Services and App Dynamics. Now, obviously for Amazon Web Services, I had to run a script to set the proper, I created an IAM account, and then I created a group, added to the group, created a policy in AWS, and I just pasted in some JSON files, which are actually in the Git, so you can do the same. To give that Intersight account access required for IWO to connect to AWS and to execute its actions. For App Dynamics, it was very simple. All I had to do was claim new target, and then I came down here. You can see you can claim targets for all sorts of hardware and clouds and SaaS-based applications. Today we're going to do UCS, AWS, and App Dynamics as our targets. So what I did was I just selected Cisco App Dynamics, Start, and I turned off Connect through Intersight Assist, and I just put basically the login for my SaaS controller here. And it established a target. So what happens when you establish a target? The same for Amazon Web Services. So for Amazon Web Services, it just wants your IAM account and password. Shortly thereafter, what it does is Intersight actually uses something called turbonomics. So these nifty little graph, I think you saw the same nifty little graph in AppD. That comes from a product called Turbonomics. So if you are kind of interested in this component, this is the AI Ops component, right, of Intersight. You can look up what is Turbonomics, comes from IBM. And Turbonomics is actually Intersight under the hood. It's one of the main components. So say you were to submit a TAC case for Intersight, our TAC would literally open a case with Turbonomics, IBM. I think that's important to know. So if you were to submit a TAC case and you don't hear back in the expected amount of time, you would want to let the TAC know that it needs to get opened with Turbonomics. They may not necessarily know that. So it's important that you have to tell them. All right. So as I can see here, I have 3 tabs: application, on-prem, and cloud. I haven't added in my UCS here. I'm going to show you how to do that. So application, this is actually connected to AppD, and it has ingested a lot of the data from AppD. And then what it is doing is it is analyzing it, and it's giving me some AI ops actions. So 6 actions that I can do, not only to make my app more efficient, but in some cases to save money. So let's just scroll down, business applications. So it's looking pretty good. 25% with no risk, 75% with minor risks. Let's just click into that and see what it means. So we have a time series graph here, and we can look at response time. Yeah, it's looking pretty steady. And we can look at executed actions. And we can sort as well by days. So we'll give it last 7 days. Okay. And let's give this last 7 days. No data because we haven't performed the action yet. And now it is saying to us, ooh, this number looks kind of high, right? This average response time. So let's go ahead and see what actions Intersight is proposing we take to improve our app. So it's saying that we should downsize. We should right size. We have a current value is 200 threads. New value, we would set 151 threads. And then it gives us a setting. So we can go ahead and we can see what the action detail is and what the impact would be. Okay. So yeah, it would go from 0.5 to 0.7, from 75 to 78.3. So we can see what the results of our AI ops action would be. We can choose to execute them up here. All right, so let's take a look at some more analysis. So here we have 33 business transactions. And let's click here, 3 actions. Again, it's telling us that we can resize this. And it gives us some capacity usage, our utilization, our heap size, and so forth. So this is very, very useful in allowing us to also save money. Oh, let's take a look at what it's saying for the virtual machine. So it's saying that the EC2 instance, or it's calling in a VM, has 1 risk. It's showing us that we're running on a T3A2 large, what the cost is per month in the last 7 days. It's showing us our capacity and usage. Can click here, show all. And that's the name of it. Yeah, that's right. And that's our AWS account number. And it's telling us that we can save $53 a month if we change the instance type from T3A2 extra large to an R5A large. And it's suggesting that based on what we have been using over its analysis. So I can execute this action. It's going to change the instance type. So isn't that cool? So yeah, anyways, why don't I go ahead and just execute it? All right, so it's executing. So we can check it a bit. We'll log into AWS console and see if it successfully migrated this. And of course, we'll see what happens to the app when it does. Oh, so app is already down. So it's already doing it. All right, pretty fast, right? Okay, so let's go, and while that is working away and resizing my EC2 instance to save me $54 a month, right? Let's go ahead and let's look at what suggestions it's making in AWS. So again, I haven't added in my UCS. I'm going to here shortly. I just had to actually spin it up in the sandbox. Ooh, so here it's giving me 54 actions for AWS, and probably they're going to be money saving actions. So yeah, it's telling me that I can reduce costs, how much per month, and it's giving me you know, some information on the volumes on the I got some GP3, some GP2, the disk size, and the cost that I'm paying per month. And what if I resize my disks, okay, what I can save, etc. So these are obviously my nodes running my Kubernetes, and then it gives me my other instances too, like my Ubuntu router. Let's take a look at this one. So tells me the region, it's in Ireland. And we know that we put the Thousand Eyes agents, right? So this is the one that has a Thousand Eyes agent on it. It's in Ireland. It's got 1 volume. Well, let's take a look at what it's suggesting for the volume. So saying, okay, I can save a little bit of money here if I go from GP2 volume to a standard volume. That's probably something I may want to do since this is just test. It's probably not going to be a huge performance impact, right? Let's go ahead. Let's look at the what is telling us. Oh, that was for EC2. Okay. So we kind of got an idea of what Intersight does. Intersight ingests our data from apt, from any hardware that we have on-prem, from AWS. And additionally, you know, there's a lot of different targets we can add in here. So it can ingest all the data. And I'm telling you, for the Cisco devices, it ingests everything, like your firmware, the entire inventory. You'll see when I add in UCS what it pulls back from us. So it's a single dashboard to pull in configuration, analytics, analyze it, make cost savings or performance recommendations, and then you can actually execute those actions that it suggests directly from in the console, all automated. So you can instantly action things. That's the AI ops. That's the IWO portion. And that's the part of the FSO stack. So, all right, so let's go ahead and I'm gonna just check to see if my UCS server came up. Okay, it's gonna be ready in 4 minutes, so we'll add it in 4 minutes. We'll come back to that. In the meantime, let's go ahead and switch over to the API. And again, InnerSight, right? There's a lot more features than what I have bandwidth to go over. You can actually create policies for like UCS boot policies. There's a orchestration feature that I'm not going over in this lab because this is an FSO API lab, so I'm really focusing on that. But if you are interested and you would like to have a much more in-depth demo or training on InnerSight, the entire product, please reach out to me, and we have a lot of those going on. So, okay, what do I need to get going with programmatic, automatic authentication? And oh, by the way, before I start on this, you guys, for those of you who don't have the hardware and you want to play around with this in your own environment, you can just go to Sandbox Labs and you can spin up the hardware, and then you can target it directly into your environment. So you actually can get your hands free for free on a lot of Cisco here, like ACI. This is all the stuff here. So I literally spin it up, plug it into my my lab, and you can do that too. It's kind of a hack. I don't know how many people are doing it, but I do it. Alrighty. So the only caveat with these is when you spin up hardware resources in the Sandbox lab and you want to plug them into your other labs, they're only available usually for about 8 hours, and then you have to respin them. So another reason why to automate this stuff. All right, so let's get going with the API. So the first thing we're going to do here is we're going to go to settings, and then we're going to go to admin. We're going to go down to API keys. My apology. Now, when we, you can see I've added in the same account, same Gmail account, and I've given it account administrator role. Now, gives me an API key. I have already updated this in my vault here under InnerSight. InnerSight. There. So it's here. And I believe this is it here. So that's it. It's already added in here. Probably I should base64 encode it. You know, another place to save secrets as well is in Kubernetes secrets, but anyways, we have done it in Vault. And now what I'm going to do is I'm going to go over to my code. Did I just accidentally close InnerSight? I think I did. Let me get back into InnerSight. My apologies. Okay, so administrator. All right. All right. So on this one, right, we're gonna run the InnerSight task. What it's gonna do is, I wanted to call this out. I'm actually using the exact same Docker image as I did for App Dynamics. The only difference is I have loaded onto it a couple of extra Python modules. I've added on cryptography, which is required because every single API call you make to InnerSight is encrypted, and it uses SHA-256. So it has to be signed. And I've also added in the Python module, which you can grab off of DevNet here. And this is a very comprehensive, if we were to look at it, let's just pull it up quick, module, which is updated on a regular basis here. And it tells you how to create objects in like a local boot disk or whatever from a JSON file. Now, where would you keep these JSON files, right? For your network. You can keep these in the vault and you can base 64 encode them. So you don't have to push any of this up into Git. So that's the proper way to do it. So there's a lot of information on here. So what are we going to use? We're going to actually use just Python request module. So one of the developers at Cisco, his name is Brian, wrote a very nice request wrapper for Intersight, and here it is. So let's just take a look at it. So this isn't mine. This is, oh, Chris Gascoigne, not Brian, sorry. And this is a request wrapper, and you can see how it uses the SHA-256 to sign, and you know, it's quite complex. So we're going to use this to help us authenticate through to the Intersight API. And this code you would need to use as well if you're going to use the request wrapper. So let's go ahead. And as you can see, I'm going to call this physical summaries. Now, we're not going to have any data because I haven't actually added in the UCS server. I think it just came online here. Looks like, is it ready? Yeah, it's active. So we'll run it first, and then we'll add in the UCS server, and then we'll run it again, and it'll come back with all the everything, firmware, power supplies, RAM, process. It's gonna every single the complete inventory of everything that's on that UCS server. So let's look at the script. What we're doing here is we're using JSON and requests as well as the Intersight auth request wrapper. And we're going out and we're getting that API key that I entered into the vault, and we're calling it secret. And then what we're doing is we're going to programmatically authenticate using that secret, and it's going to use our Intersight auth request wrapper, pass this info, and it's going to authenticate through to the API. And then it's going to run an API call called compute physical summaries. Now, where did I get this? And then of course it's giving us our response back, and we're going to print it out both in text format and JSON. And yesterday here, I was actually writing the payload out to a file. I'm going to comment that out for now. So we don't need to do that. All right, so let's go ahead and run it. And remember, we haven't added in the UCS. I'm going to show you how to do that. So we're just going to do, pardon me, fly. Oh, by the way, you may have automatically logged out of Concourse when you stepped away from lunch. So I would recommend that you just, log back in. Right, we're good to go. And now we're going to do fly target, Cisco FSO labs, E execute -C, our config file, and then our task, which is Intersight task. Right, and it's going to run. And we're gonna get something back, but we're not going to get a physical summaries because we haven't added in UCS. And now what I'm going to do while this is running is I am going to set a target for the UCS server. So to do that, I have to actually, 1 second here. Just gonna add in the UCS server while this is running. Bear with me. So after you spin up some hardware in the Sandbox Labs, you get an email and it gives you instructions on how to connect to it. Now, hopefully this isn't going to kill the WebEx. If it does, I'll be right back. But in order so that I can SSH or connect to the UCS server, oh, you know what? Maybe I don't need to. Hold on. 1 second. I may not need to. I may be able to hit it straight off the internet. Just hold on. These are pretty wide open, these environments. I may actually just be able to hit it right off the internet overview. All right. So yeah, I think I can just hit it directly off the internet. Yep. So let's just get the IP address of this thing. Credentials, UCS. All right. Let's try this IP. See what happens. All right, so I should be able to hit it here. So I'm going to minimize this. And let me just open another window so we can toggle. Well, we're going to just put it here. Pig. And let's cross our fingers and hope that it comes up. I know it's usually a little slow coming up.
Hey, Sherry, normally for the DevNet, you need a VPN connectivity.
Do
Then
I?
you can reach-
Okay. Okay. Let me connect it up real quick. I thought so. I did this yesterday, but
No, not this VPN. There's in the email DevNet.
Oh yeah. Oh yeah. I know. Yeah, I
Connection
know.
will be there.
I know. I know. Yeah, you're right. I have to do that. Okay. So let me get out of force quit. I wasn't connected. So in my email, yeah, Manoj is right. It's all coming back to me now. So if I look in my email, right?
Yeah, it's
Initially,
here. Detail.
I have to connect here. So it gives me, so I gotta fire up Cisco, oh, here it is. And I just paste in the link here, connect, and it gives me the password here. And it's going to connect, and then I should be able, yeah, here we go. Lock and load. All right, so UCSP, this is how I log in. Launch UCS Manager. And it's actually a little slow because this is obviously a sandbox environment, so it's like bottom tier for performance. But yeah, this thing is actually a piece of hardware sitting somewhere. I think it reconfigures itself, right? Right, Anosh? It's actually a piece of hardware, right? It's not a NED. Pretty sure.
It's emulator.
Oh, it's an emulator. Okay, that would explain why it's so slow. So this is kind of like a virtualized emulator of this hardware, but it for the purposes we need it for, it works. So I'm gonna log in here, and then I'm gonna go to Intersite, and I'm gonna go target, and I'm gonna do claim target, and I'm gonna go UCS server. I'm gonna queue this up, and I'm gonna have to input a device ID and a claim code. And I'm gonna generate those on this UCS server as soon as it logs me in. And I'm sorry it's so slow, but it's free. Free stuff is sometimes slow. All right.
I think it's a good hack, right? So you're trying to, take the UCS DevNet manager and putting into the Intersite.
Yeah, I'm showing them how to do it so that they can go and they want to add in all the Cisco hardware into their intersite for free. This is how you can do it, right? You don't have to actually have a VPN connection between Intersite SaaS and the UCI. It is able to connect somehow. I don't know. They have the ports open in the back end somehow. So, wow, it's really slow. Oh, sorry, guys. Just give it a few more minutes here. Logging in. I'm just gonna hit refresh. It's gonna want me to log in again. I shouldn't have done that. Okay. All right, and let's look at the instructions then for how to generate that device ID and target. Oh, yay! Yeah, don't show this message again. Call home. Don't need that. All right. So, all right. Well, this is actually spun up like quite a bit of architecture for us. It's spun up a couple of fiber interconnects. Oh boy, yeah. So this actually just spun up this entire architecture automatically. And now what we're going to do is we are going to generate device ID and claim code. We're going to enter it into Intersite, and then Intersite is just going to suck in all the, or suck in is ingest everything about these hardware. So let's go ahead and do it. And actually, I believe I have to go into admin. See if I remember how to do this. Admin. Scroll down, device connector. And that's the device ID. Copy. Put that here. And now,
You need to refresh. It will just on the top right, refresh. It will.
okay. Okay. So, not claimed. So here's the claim code it generated. I'll put this in here. By the way, guys, this device connector, you can load it via a Helm chart onto Kubernetes clusters, and you can target your Kubernetes clusters directly. I have tested that. I'm not doing it today, but let's go ahead and claim it. And it's been claimed. Sweet. Now let's go back and let's look at our response. So remember, before we added UCS server, we ran an API query and it's come back like this. So our authentication was good. We got a 200 response, but obviously at that time we had no. So let's rerun it now that we have, or actually, let's just wait a couple minutes. Let's give Intersight just a few minutes here to kind of go out with its octopus tentacles and collect all the information from the UCS server. All right, let's try it, see if it has gonna bring back all the data from it. Okay. And if I wanted to speed up the build of this task, instead of running a git clone on installing this Intersight Python module each time, I would actually bake it right into my Docker image. But actually, I don't mind doing it like this because I'm going to get all the latest updates. And there is a lot of heavy documentation being done on this right now. So there probably are updates since yesterday. All right, it's just installing the Python cryptography. And that's another thing, if I wanted to speed up the build of this, I would just add that module directly onto my Docker container. And by the way, this is why we have pipelines to build our Docker containers. So I'm going to just show you quick while we're waiting for this to run. Oh, and see, look, it ran. And look, it brought us back everything from that UCS server that we added in. So this is great. So how did I know And you're going to notice that there is this concept of MOID. Generally speaking, when you are running any sort of post operation to Intersight, you are required to post it to a MOID. Therefore, you need to be able to negotiate the payload from the API to extract out the desired MOIDs. So you can see that this JSON is a fairly simple format. It looks like at first glance, we have a list of dictionaries, but look, in some of those dictionaries, there's another list of dictionaries. So depending on, and now this is going to be different from what it brings back from the cloud, from what it brings back from App Dynamics. So when you start writing your automation code for Intersight, the core skill that you need is very advanced Python, JSON, or Ruby or Go or whatever your language is. You really have to know how to negotiate and have advanced skills in that regard, right? So if you're going to spend time on learning anything, I would spend time on that because Terraform can't do that for you, and there's no tool yet developed by the human species that can do that. So you have to be able to do it yourself, is what I'm saying. All right, so how then did I figure out what was the correct API call? Well, Intersight, and you're going to be really excited when you see this because none of the other products we've looked at have had this. It actually has a kind of like API browser. So if you want, you can just Google it. Oh, I wonder if our app came back after Intersight resized it. Maybe not. Okay. Oh, no, actually, I'm on the VPN. I can come off the VPN now that I actually set my target. Okay, this might be still resizing. So if we were to actually just say we didn't know, we could just Google Intersight API. And if we go to API docs, because I'm already logged into Intersight, it will actually take me in and it gives me a very detailed description. So you can see here that this API, like App Dynamics, is written to the Open API specification, formerly known as Swagger. And the Open API document itself is based on version 3. And Thousand Eyes does not have a Python SDK. Intersight does. App Dynamics does not have a very comprehensive SDK in this version. They're putting all their effort into developing it for their cloud, their new cloud version that they've just released. But Intersight has a very comprehensive, detailed SDK, Python SDK, and as well, there's a lot of development going on in the back end in this product. And on top of it all, this product talks to all the other Cisco equipment, as well as any targets via their APIs. So the development that's going on in the back end of Cisco Intersight is actually from Intersight API to those APIs, okay? And just if you're interested, this SaaS Intersight, which is running up in the cloud, is using a Mongo Atlas DB on the back end. All right, so let's go ahead, and if we go to API overview, or sorry, API reference, we actually have an interactive, or we have a list of everything we can do from this API. And as you can see, it is a massive list. So we have this nice little search function up here. If I want to look for something physical, I can just type in physical, and it will show me everything to do with physical. Now, I was running compute physical summaries, and so I can come right in here and look what happens. It brings up this interactive window, and I can send this query, and this query actually sends through and it executes on what is in my intersite. So this is fantastic. This is incredibly helpful. Not only does it give us, it gives us the URL suffix to for our REST calls, but we can actually run it here and make sure it brings back some data. And we can kind of have a data preview of the JSON. We can see the results are, and it gives us a description. This is the object type. And our result is a list. We can see it's a list of dictionaries. And then inside of those dictionaries, there is, sometimes there's more nested data. So overall though, this really is not very complex. This is very easy to negotiate in respect to the JSON. The tricky part here is to know what MOID that you need to extract for your next set of instructions. So at this point in time, I'm going to pose a challenge to you guys. What I request that you do is you log into Intersite, and I set you up with the same account. Let's just verify works. And what I would ask that you do is browse that API GUI and just run some API calls through that graphical interface. And when you're happy and you have one that you like that is bringing back some interesting data, go ahead and update the script here. So you can make a copy of it and rename it, or what you can do is you can just comment out. Oh, actually, I ran it on physical disk. You can just comment out and put, the API link that you want to run it against, and then build it in your container. Okay, so let's just make sure that you guys can get in. Anoj, maybe I'll have you test this account to make sure you can get in with it, because I set you guys up with an account. So let's just go users, make sure I did indeed. Okay, let me add in that user. I guess I didn't add it in, my bad. So this is going to be, you know what? I didn't, it looks like I didn't sign up. I would have to use an alternate Cisco account. So,
Not allow Gmail account, I think, Sherry.
No, because Cisco is a provider, you see. So you have to actually set up an account with Cisco. Maybe I can do it real quick. Hold on. Set up a Cisco account. And I can do it with that account. Let's just try here. Okay, maybe I'm not going to be able to do it. Oh, I'm sorry. Okay, so next plan. Next plan
So,
is
Sherry, just one thing. It's all here a Cisco, right, team. So they should be able to log into the Cisco site direct with their Cisco IDs.
Yeah, but I would have to give them access into this instance of Intersite, or they're not.
Okay.
Yeah.
Yeah.
Yeah. So apologies, guys. I won't be able to get you into the console right now. So what I'm going to suggest you do is just go to the documentation online for the API and run the queries in your automation task. Okay. So I'm going to run a couple of different queries. So the one I actually just ran was the storage physical disks. I'm going to now comment this guy out, and I'm going to run get physical summaries. Wrong tab, here we go. You can see here it brings back like firmware type. And how might this be? Say you have 100, 200 Cisco routers and you want to know what all their firmware is. You can just run an API query filter out the firmware, the MOID, and, you know, the name, whatever. And you can have everything in an Excel spreadsheet or a JSON format or into a database that you can SQL query. So let's go ahead and let's rerun it. And now I'm running the physical summaries. Let me put the links here into the chat. So InterSite API docs. So you should be able to access these. And guides, supported HTTP methods. So get, post, patch, delete. It gives you all the methods, and then it gives you some specifics on the headers. But actually you can use, so here it ran. And it's coming back with the total memory of this device, the UUID, vendor, licensing tier. This can also be good. I actually, I think one of our partners on the call, you have developed your own software, which goes out and it extracts the licensing information in an automated way from all of the software and everything that your customers are using. And then based off that, you take it into a database, you run reports. And so you know if there's a license somewhere that's going to expire, you can proactively reach out to the customer and make sure you get the renewal on track. So you can also do this by making API calls. If you're managing all of your hardware through InterSite, it makes it very easy. Now all you have to do is run an API call against InterSite and you get all that information instantly. So these are some of the business use cases for using the API. Now, when you get into actually making post commands against InterSite, it becomes very, very complex. I don't think we're going to have the bandwidth because we're dealing with IWO. This is an FSO API lab. We're not going to really have the bandwidth, but you can actually create entire policies for your equipment using the API post commands from YAML files. And that's pretty advanced. So you would have to have a lot of prior knowledge in regards to configuring, obviously the switches, the routers, the UCS. So I won't have the bandwidth to get into that here, but you can do it. So, all right, I'm going to give you guys, it is 12:52. Please go ahead and explore this API. Make some, go to the API reference and you can pick out something of interest here. So let's see, I'm going to look under physical again. So physical summaries, compute, rack. Let's look at rack units. I'm going to run this one. So this one has a get, a post, a patch, and a delete. Let's run the get and see if it brings back anything. So I'm going to test it out here and it does. So this is one you could potentially run. All right, I'm going to update my code and run this, and then I'm going to see if I can do a post against it. So let's see what we need to do a post. So first of all, let's go ahead and I am going to just say instead of physical summaries, I'm going to do rack units. Rerun my task. All right, let's read the documentation here and see how we do a post or an update or a patch. Let's see what a post does. Okay, so for the post, the parameter that is required is the MOID. Okay. And the request model is here. Okay, and the response model And let's just test it out through, I'm going to test it out through the GUI first, and then if it works, I will write the Python to automate it in my task. So let's go ahead and take a look here what it brought back for me. It should just be one rack unit, right? Holy smokes. Yeah, I guess that's why I put this to a file before, because it's massive. Get to the top of it here. Wow. It's a lot of information. Still not at the top. Holy smokes. Oh, that isn't even all of it. Look at, I can only scroll up so many lines. So yeah, this is one actually that I will play around with in a Jupyter notebook to try to figure out this JSON blob. Oh, and look at, this is interesting. Even in the JSON blob, it gives us hyperlinks to information about the API here. Okay, I'm actually not ready to post on this one because I'm not sure what MOID I would use or what it is that I want to update on this resource. So we'll just leave that for now. I think on this one for now, let's just run our get commands. If any of you feel very ambitious, and you feel like there's something parameter that you want to change on here, go ahead and run a post command. But I'm not really 100% sure what change. Oh, ports, channels. Okay, maybe I can make a change to a port. Let's see here, fabric, don't want to touch that. Firmware summaries, let's run this one. Okay. So firmware summaries, let's do a get on that. Run it again. Okay, it's not coming back with anything. All right, guys, I'm going to give you, it is 12:57, 3 minutes to run some API calls against Intersight using your automation task. You're going to have to do it that way. And, oh, this is interesting. We can run IAM post commands, which will bring back the AWS certificates. Interesting. Let's see if we have any appd. I doubt we do. We have some Kubernetes. Now I should note that these Kubernetes are for Kubernetes that you are actually running on Cisco hardware. So on our Cisco switches and so forth, you have the ability to actually deploy Kubernetes right onto the hardware. And when you're browsing the API here, the Kubernetes, that's what it's referencing. It's referencing Kubernetes clusters that are actually running on your Cisco hardware. So we don't have any running on this hardware. Ours are running up in AWS. Memory arrays. Okay, memory arrays brings back something. And it's pretty massive. So I don't think we can post on that either. Networking policies, let's take a look at this. There's no policies applied. VLANs, port info. Oh, here we go. So it's pretty massive too, not as big as the rest. Okay, let's see, maybe this is one manageable bite-size chunk. Maybe we can modify the tag or something on here. So I'm just going to update my task with this. Let's run it. Arrow up, boom. Oh, by the way, I should know with the authentication through to the API, every time it's generating a new token, every time. So that's every time this script runs, it's writing the new one to the vault. So that's just something a little bit different than the others as well. All right, I'm gonna challenge myself and see if I can't post against this to tag it or something. So I'm just gonna look at the quest model, response model. Here, I'm gonna put the MOIT of, oh, so now it's saying invalid API key. So it looks like maybe verify API key ID or account retry operation. So let's just retry it again. It could be that my API key is expired. The one that's in the vault, because I did set it like a couple weeks ago. I can't remember how long it's good for. So if it doesn't work, we'll just, it's probably time for me to rotate it anyways. See here. Okay. So after you guys have played around with this API and hit some of the API URLs using the automation task, I'm going to break for questions. So if you have any questions, please dump them in the chat channel. If not, what I'm going to do is let me rotate the key here quickly. Admin and account admin and API keys. Generate API key. And I believe we're going to do schema 3. So API key, vault. Oh, I was using V2 here. Oh, actually, you know what? I think I was using both versions. So let's edit this guy. Save. So actually, I have actually added a key and RSA here. So that's really important. This is for, so there's 2 versions. Here is the RSA key. Adding that to the vault. It's good actually that we did this because I forgot about this. Save. Okay. So now should we get to go? I think. Try again here. All right, so after this runs, we're pretty much done with the APIs. Let me just go ahead and review what we learned here. So what we learned after the break was how to programmatically authenticate to the AppD and the Intersight API. And okay, that failed. All right. Anyways, and we were able to find how we can follow the documentation to update the API information. We learned in the Thousand Eyes portion how to negotiate JSON, both locally using our Jupyter Notebook. And so based off the code you have here, you're now fully enabled to make any API calls you want onto these APIs, get any of the API payloads back. You know at a high level how to massage the data, how to extract key value pairs, send them as variables and use them as input into later processing steps in your code. So at this point in time, you have all the tools to get up and running and start developing code to these APIs. You've also have learned how to do it by integrating with a Vault and a CI tool. And there's a tornado outside my house right now. Ooh, wow, it just blew up. That's what that sound is. I just like heard this crazy sound and I looked outside and I saw a tornado. It's gone already. All right, now what I'm gonna do is, it's pretty early. I'm gonna just spend a little bit of time here explaining if you would like to deploy this lab into your own AWS account, which I recommend. There's a few manual steps, but most of it is automated. So I'm just going to show you what that is. And why would you want to do this? Well, and I would suggest that you set up a separate AWS account. So if you remember in the commercial for this lab, it said you can run the whole lab for $1 a day. Well, in fact, that is true. How is that true? Well, if you create a new AWS account and you can fully automate the deployment of the underlying code infrastructure, including the Kubernetes clusters, all the apps, everything into your own environment. And if you shut it down at night when you're not using it, right? And you respin it in the day, it's all code. So you can actually delete it at night, redeploy it. It takes about 12 minutes. You can have this entire lab, including the CI tool, Concourse, including the Vault, everything up and running in your own account for about $1 a day. So you just have to turn it off at night. That's based off of turning it off 8 hours a day. And in that way, you can integrate with your own products, your own single sign-on, your own hardware, and you can start developing code to work with these APIs that you can incorporate into your own products. That's the objective of this training. So let's talk about if you wanted to do that. Now, if you wanted to do that, I'm just going to log into AWS so I can kind of give you a and I was expecting like I think around 38 people registered. I thought it was going to be 38 developers running a lot of the concourse tasks. So I normally run a 2-node cluster. I think I scaled it up. I scaled it up way too big. I scaled it up to like 5 nodes, so it would be fast for you guys. But I see that's not necessary now. So when I log in, the cost may show as like a little as more than what I said, $1 a day, but that's because I scaled it up so massive, expecting a higher volume. So yeah. So the entire lab infrastructure is just running on this cluster, which I scaled up. I'm going to scale it back down as soon as we're done here. So this is a COPS cluster. If you wanted to deploy this, right, you could deploy it from a task. There's a directory here called LabCube, create cluster. There's actually an automation. If you run this automation task, just the way we've been running the others, it's going to pull the COPS Docker image. And then what it's going to do is it's going to deploy your cluster into AWS And now you have a Kubernetes cluster. Then what you're going to do is you're going to deploy onto the Kubernetes cluster two Helm charts, two vanilla Helm charts, Concourse and Vault. Now you're going to follow the Vault instructions to initialize your Vault. It's very simple. You just exec onto the node, initialize your Vault. Then what you do is you generate a token for Concourse, and then you do a Helm upgrade to include the token in your values file. And now you have a full integration with Concourse and Vault running on your Kubernetes cluster. Then, if you like, you can also set up an integration, which I have done between AWS and Concourse as well. And it's all documented in here. So you just have to execute the tasks. If you want to execute it via a pipeline, there's a pipeline file in here, v3. If you set this pipeline and there's instructions in the README, it will look something like this. Let me log in here. So when you set the pipeline, you're gonna be able to log in to Concourse console, and you're gonna be able to, whatever pipeline you set, you're gonna be able to see it here. What it's gonna do is it's gonna pull from Git all the code, deploy your AWS environment. In the AWS environment, generates a key, which all your instances, if you decide, you spin up resources as you need them. So say you want to bring up some Thousand Eyes agents, some CentOS, you would bring up the instances, and then you would deploy the agents. This has a CSR in here. I'm going to be replacing this with a 8000K switch very soon. So once you have the pipeline set, you can deploy everything via the Concourse pipeline, all the underlying lab infrastructure. Once that's up and running, you just come in and you just run your tasks like we've been doing. So it's very simple. It's very easy. You can delete it. You can delete the entire, what it does is it spins up a VPC here. So you can give everybody, all your developers, a different VPC, their own little playpen. And you can delete it at the end of the day. You can spin it up the next day. It takes 12 minutes. So if I were to go into VPCs here, you will see that I have spun up a couple VPCs, I think. Okay, in Ohio, I did it. Yeah. So I have a couple of VPCs that I use the pipeline. So when the pipeline builds a VPC, it also creates some subnets, and it also creates route tables. And if you look at the route tables, it also creates internet gateway. And so it gives it fully configures a availability zone, which is an isolated environment for each developer, in order that they can develop code to these APIs and have the underlying infrastructure run up in AWS. So it's about $1 a day. So it's very inexpensive. And the Concourse ephemeral build containers, because they are ephemeral and garbage collected, after you've developed your code, they go away. So they almost cost no money. So it's kind of like a free way of building your code up in AWS. It's close to free. So at the end of the day, really the only thing that you would be paying for is whatever you turn up here in AWS, and you can get eval licenses for all of the products I've gone over here today. So if you want more information or you need help to spin up your own instance of this lab in your environment, let me know. I have some videos on it that will walk you through it. There are a few manual steps. I have some scripts to set up the IAM on the initial AWS account and so forth. So yeah, that's it. I think we've actually covered all the material much faster today. It is a lot of material. It's 3 different products, 3 different APIs, totally different. I will stay online on the chat in case anybody has any questions or need any help. But I think we're going to conclude the training session today and give you folks back some time. So any questions? Stop the recording.